I'll be talking about Spectrum Manager version 1.2, which is the new release of Spectrum Manager. So what is Spectrum Manager? Spectrum Manager is the next evolution in the AFGROW spectrum generation using XML capabilities. It's used to create spectrum files that you can use in AFGROW for predictions. You can create, edit, and view spectrum data through the multiple detailed windows, and the resulting spectrum files will always be cycle counted. So, to create a spectrum from min and max data, first you would select the new project menu from the application menu. Then you would enter a subspectrum name, a subspectrum label, and a description if you want that. Then you would select the Create Subspectrum with Min-Max data option in the new project dialog, and then select any additional options that you would want that spectrum to include. Then you'd click Create. So that would take you to an empty project, and from there you would create a new subspectra or import a previously exported subspectra. The subspectra, like I said earlier, are always formatted in max, min, and cyclic data. Then you would use the GUI to edit each individual level of the data. You can create a sequence from the project subspectrum library. So if you create multiple subspectra, you then use the sequence to add those to it. And then once a valid sequence is created, you can save the spectrum. So the first view I'll talk about is the project window, which by default is located on the far left of the Spectrum Manager application window. It has an expandable tree with the names of the subspectra as the root, and then it lists all of the subspectra underneath it. Selecting the subspectrum name will display the data for the entire spectrum in the spectrum data, spectrum plot, and property views. And if you select a subspectrum name, it will display in all of those windows just the data for that subspectrum. If you select the sequence, it will bring up the sequence data view, which will list all of the subspectra that are currently in your sequence. Spectrum Manager has an exceedance plot. It displays the cumulative number of stress or load values in the spectrum. The legend lists the max values in red and the min values in blue, along with the corresponding number of cumulative cycles. The R plot displays a range of stress ratios versus the number of cycles for the entire spectrum. Users can plot R values from anywhere from -100 to 1. The legend lists the range of stresses or load ratios in the spectrum with their total number of cycles. The delta plot displays the range of spectrum stress range values or delta values. The legend lists the number of occurrences of the delta value for each level. The 3D plot is a combination of R and delta plots. You can hover over any desired bar to see the number of occurrences in that bin value. The plot can also be zoomed and rotated so that you can see the data from any angle. In the sequence data window, this is what is actually considered to be inside of your spectrum, and it's what subspectrum AFGROW will use when you're actually running a prediction. A user can place a subspectrum from the library into the sequence in any desired order, and you can also use any of the copy and paste capabilities in order to rearrange your sequence. In the spectrum data window, if the spectrum is selected, then it will present a read-only version of every single min-max pair in the entire spectrum. And if a subspectrum is selected, then it will be a writable version where you can actually edit the min and max and cycle datas within the window. And then all of the clipboard functions are also available in this view. The spectrum plot, which is located at the bottom of the application window, is a visual representation of the spectrum. This shows either the subspectrum or the spectrum's stress versus cycles plot, depending on what is selected. The cycles are plotted as vertical lines indicating max and min pairs. The properties window is normally located on the far right of the Spectrum Manager application window. And when a spectrum is selected in the project window, the properties and statistics of the entire spectrum are shown. When a subspectrum is selected, the properties and statistics of only that subspectrum are shown. You can edit the subspectrum and spectrum name and descriptions in this window. Subspectrum has a number of commands that can assist you when you're trying to edit your spectrum or create one. The first one is an export subspectrum option. You can save or export a single subspectrum from your spectrum. To do that, you just click the Import Export Subspectrum button and select Export. And then you can either select a subspectrum, or you can select a subspectrum and then navigate to a path that you want to save it to, and then click Save. To import a subspectrum, you go to the Import Export Subspectrum button, and then click Import Subspectrum. And then you navigate to the path of the file that you want to import, and then select Import. When you import a subspectrum, it won't be automatically added to the sequence. You'll still have to do that manually. There are a number of clipboard options listed in the ribbon menu at the top of the screen. These will only be available in the sequence data and the spectrum data views, and they provide all of the basic editing functions that you would need to rearrange your spectrum. The reverse option multiplies the stress values by -1, which will invert the spectrum. An example of when you might want to do this is if you wanted to simulate a lower wing spectrum and you only have an upper wing spectrum, or vice versa. The clip option limits the stress values or load values for the entire spectrum or for the selected subspectrum. If the max value of any level exceeds the upper bound of the clip option, then the max for that level will be set to that upper limit. The truncate option limits the delta values for all of the levels in a subspectrum or a selected subspectrum. It removes any level that has a delta value less than the value that you selected. And if a subspectrum would have all of its levels deleted in this way, then the user will be prompted to delete it. The normalize and denormalize options are also available. The normalization option divides each max and min value by the factor entered into the dialog. By default, the normalization factor is set to the value that will result in a spectrum with a maximum value of 1. The denormalization box will multiply each max and min value by the factor entered into the dialog. Okay, the random subspectrum option arranges all subspectra in the project's subspectra library into a sequence of random order. Each subspectrum will appear in the sequence a number of times equal to the occurrences next to the subspectrum name. And it uses a seed value that you can edit in the project options window. When you use this option, it will overwrite anything you had in your current sequence. The randomize sequence option is similar to the randomize subspectrum option, except for it will take the number of occurrences that you already had in your sequence window, and it will use that for the randomization. So anything that's currently in your sequence that you've built yourself will remain the same, but the order will change. And it also uses the seed value that you can set in the options window. The randomized level option will shuffle the orders of the levels in the subspectrum by levels or by cycles. Randomized by cycles splits each level into a number of levels with one cycle each, shuffles them, and then combines adjacent equivalent levels. To get to the preference options, you would go to the application menu and then select options. In this menu, you can enable damage tags, environmental tags, or time dependence in your spectrum. You can also interchange the X and Y axis of the exceedance chart, and you can set the text size, number of decimal places, and the seed value for all of the randomization functions. After you save your spectrum to a file, you can then open the spectrum dialog within AFGROW, select Open Spectrum File, and then navigate to your saved spectrum and click Open, and then you'll be set to use your spectrum in an AFGROW prediction. All right. Now I have a short presentation about spectrum generation within Spectrum Manager. When you go to your application menu in Spectrum Manager, and then you click New Project, there will be an option that you can select Generate a Spectrum from Exceedance Data. And when you click that, you'll be presented with this. This is where you can paste your exceedance data into the window, and then you can click Draw to see a visual representation to make sure it's right. The exceedance data needs to be cumulative, and then the total occurrences in both the max and min column have to be the same. There are a couple of methods that you can use for generating spectra from exceedance data. One method is the random pairing method. It pairs levels randomly while maintaining the original exceedance curve, and it generally produces a spectra that has longer life predictions. There's also the incremental method. It pairs levels systematically with an algorithm, and it generally produces a spectra which will result in a more conservative and shorter life prediction. There are a few options for generation: the subspectrum options, ground-to-ground cycles options, the reversal output options, and the random generation options. And I'll touch on each of those real quick. Subspectrum options. This option basically lets you either decide to use a set number of subspectrum and then divide the number of cycles equally between them, or you can choose a number of flights per subspectrum approximately, and then change the number of flights based off that number. There's also an option for ground-to-ground cycles. It pairs one high and one low exceedance point in order to simulate a ground-to-ground cycle. You can put this ground-to-ground cycle either at the beginning of a subspectrum, at the end of a subspectrum, or at a random location in the subspectrum. The reversal output option ensures that the max of a following level is greater than or equal to the min of the previous level. This option has a failure rate that's relatively high, especially if the exceedance data that you're putting into it wasn't originally meant to be formatted this way. When it fails to ensure a reversal, a warning will be issued with an opportunity to cancel and change your options, or to change anything you want to try and guarantee that reversal. There are a couple random generation options. You can set the random seed, which this random seed is different than the one in preferences, so you can edit it separately. For repeatable randomization, or if you want to generate multiple randomizations with the same parameter, but a different seed, you'll get different results. You can set a minimum delta percentage to change the behavior of the randomization. These delta stress values are just the difference between the maximum and minimum values, and then the minimum delta percentage will just filter out anything that's too low under that percentage. I have a couple generation suggestions just based on what I've seen while I've been working with it. It's based on a small sample size, so these are just suggestions. For spectra with very damaging cycles or with high delta values, I would recommend using the incremental method for a more conservative approach. For spectra where you don't expect that, or for a less conservative prediction, you can use the random pairing method. I found that works better with maybe transport spectra. And for additional adjustments, you can use the minimum delta percentage option, usually between 5 to 15%. Raising the minimum delta percentage usually results in less life predictions. And I would just add in here that these are all numerical methods, so it's up to the user to decide what they want to do with it. Now I just have a few slides that show examples of the deltas in a spectrum before and after generation. So here is a sample fighter spectrum and the delta plot that corresponds with it. Here's that exceedance data from that spectrum put through the generation, and then you can see the difference in the delta plot. Here's the random method for that fighter spectrum with a 0% delta filter. Here's a transport spectrum, original. Here's that transport spectrum with the random method with a 0% filter. Here's that same spectrum with a 5% filter, a 10% filter. And then here's that same spectrum with the incremental method. And the point of this was to see that if you look at the original here, you can see that this method is probably a little bit more accurate than this one here because it matches closer.